For the past 2 days, we've been working on ionic bonding and something called nomenclature. And that means we are looking at the ionic bonds and how you name them. So this is just going to be a little tutorial to kind of bring you up to speed in case you've been out, or to use as review on the ionic bonding and the periodic table. So this is what we did in class together to start off with, is we talked about what ionic bonds are. Remember, they're made between elements due to their charges, and we talked about ions, and we talked about on the periodic table. And if you don't have your periodic table labeled, you need to get it labeled. We've labeled these in class. I know some of you have lost your copies, and I've given you extra and extra and extra. If you need to go to print one out, we're using the ones that will be given to you. Okay, so if you need to, we're using the one from, if you just type in, if you Google it, or if you get one out of my orange crate, I'm using the one from the Georgia EOC periodic table. And so it's the one you will see again on your EOC. Of course, the one you see on your EOC is not going to have all the notations on it. It's going to be a nice, clean, blank copy. But the more we notate on it and use it in class, the more familiar you will be with this table. So this is the one we're using. So what we're looking at, remember we put the valence electrons on. We did that one day, like a week and a half ago, and we came back and we put in our oxidation numbers. Remember, oxidation numbers are how many electrons they're going to gain or lose, and so everybody in this family is going to lose 1 electron, which is going to give that atom a +1 charge. Everybody in this family is going to lose 2 electrons, giving this family a +2 charge, and so on and so forth. Your transition metals right here, the oxidation numbers are going to vary. Family 13, 3 plus. Okay, so that's the oxidation number. They have 3 valence electrons, but their oxidation number is 3 plus. Family 14 has 4 valence electrons. They're going to lose all 4 if they bond ionically. Family 15 has 5 valence electrons, and they're going to take on 3. So that's why they have a -3 charge, because they're going to gain 3 electrons when they bond ionically. Family 16 has 6 valence electrons, and when they bond, they're going to take on 2 more to be full. So that's a -2 oxidation number. Number 17, family 17, has 7 valence electrons. So they're going to take on 1 or gain 1 electron. So they're going to have a -1 charge. And your noble gases are 18, and they have 8 valence electrons. So they're going to have an oxidation number of 0, because they are not going to gain or lose any, because these guys are called inert gases or noble gases, or they are stable, or their outer shell is full. So they're not going to bond. They're non-reactive. Okay, so that's the periodic table where we're looking. And remember that ionic bonds occur between metals and non-metals. So you're not going to have 2 metals bonded ionically together, and you're not going to have 2 non-metals bonded ionically together. This is only for a metal and a non-metal. And your metals are going to have your positive charge. They're going to give away your electrons. And your non-metals are going to have your negative charge, because they're going to gain your electrons. So the very first thing we started off with was chemicals, compounds and chemical formulas. So we looked at how to read a chemical formula. And so, for example, you have something that looks like this, Na2S. So what do you do with that? What does that mean? So first of all, we look at this subscript. That subscript is telling me how many atoms I have of this element. So Na stands for sodium. 2 means I have 2 atoms of sodium. S stands for sulfur. And this one doesn't have a subscript, so we assume that that's 1. So that means I have 1 atom of sulfur. So that's how I fill in my chart right here. We're just identifying how many atoms of what elements that I have. So I have 2 atoms of sodium and 1 atom of sulfur. In this one, I have magnesium and I have sulfur. Notice that you have a capital letter here, and you have capital letter here, and the G's a lowercase. So capital and lowercase, Mg, go together. That's magnesium. Capital S, that's sulfur. So Every time you see a new capital letter means you have a new element. So it's important, capitalization is important when you're writing your chemical formulas, chemical compounds. All right, so we have 1 and 1 because this one again does not have a subscript, so we assume there's one of the Mg and one of the S. So Mg is for magnesium, 1 atom of magnesium, 1 atom of sulfur. Right here we've got Fe, which stands for iron, and there's one of those, so 1 atom of iron, and I have 2 atoms of chlorine. Cl is chlorine. K2O, 2 of potassium, 1 of oxygen. Cui2, Cu is copper, so I have 1 of copper and 2 of iodine. Ki, K is potassium, I is iodine. 1 and 1, 1 of potassium, 1 of iodine. Ca is calcium, S is sulfur, 1 and 1 because they don't have a subscript. 1 calcium, 1 sulfur. CuF2, move that up. Copper, fluorine, 1 of copper, 2 of fluorine. See right here, Cu, I don't have a subscript, so that's a 1. Li and O is lithium and oxygen, 1 of lithium, 1 of oxygen. Fe and S, 1 of iron and 1 of sulfur. So that's the way we read a chemical compound. All right, the second part was we added to this of how to name these ionic compounds, and it's pretty easy. What you have to do is you use the metal's name and then you change the ending of the nonmetal to IDE. Some of these are going to sound a little strange at the beginning, but the more that you hear them over and over and over, the more normal they're going to sound, and the more we use them in class, you'll become used to the way that they're named. So this is Be, which stands for beryllium, which is my metal, and Cl stands for chlorine. And we're going to add that, we're going to take the chlorine and make it a chloride. So that's beryllium chloride is how we would name that one. Ca is calcium, S is sulfur, but because they're bonded together, it's not sulfur anymore, it becomes sulfide. Okay. Sodium is Na, so it stays sodium, if you can read my handwriting here. And S is sulfur, and again, sulfur becomes sulfide. Copper, and then fluorine is what it's bonded to, so once it's bonded, it's not fluorine anymore, but it's fluoride. Okay, you know you've heard of fluoride before, fluoride to make your teeth strong. Magnesium is Mg, so that's magnesium. S stands for sulfide. Lithium and oxygen become lithium oxide. Iron and chlorine become iron chloride. Iron and sulfur become iron sulfide. Potassium and oxygen become potassium oxide. Aluminum and oxygen become aluminum oxide. Copper and iodine become copper iodide. That's a weird one, iodide. Aluminum, this one looks funny, but it's aluminum, Al, and N, which is nitrogen, become aluminum nitride. Okay, so that's the way that we name them. Oh, we got a couple more. Oops, almost missed them. All right, Ki, potassium iodide, and then Bai2 is barium iodide. Okay, we're just naming those, and very, very similar pattern all the way through. All right, on the back side, what we went over, so we did all that together in class, and then we went over these, and we talked about, okay, we took it a step further. You can look at a formula and give me the name. So this step is going to be, if you look at the name, can you give me back the formula? A little more tricky, I guess you could say, or a little more steps. It's really not bad once you get the steps down. So first thing that we're going to do, given the ionic name, we can determine the chemical formula for that compound. So first thing I'm going to do is I'm going to identify the elements. I'm going to get their oxidation numbers. That's important. They're positive, negative. And then I'm going to use subscripts to balance the charges. Remember the subscript, like if I put Ca, which is calcium, is a 2+ charge, and if I have 3 of those, that means this number here is my subscript, and that tells, if you need to write this down, this is on your notes, how many atoms there are. All right, so for future reference, calcium 3 means really that I have 3 calcium atoms bonded together. Okay, there's 3 calcium atoms bonded together. Okay, so if I think about that in terms of charges, each one has a 2+ charge. So if I look at this as a molecule, let's say 2+, 2+, 2+, right? Positive 2, positive 2. That's going to give me a charge of 6 positive for this whole molecule. See what I'm saying? So this is all the molecule. Now, up here, I can determine that without having to draw this picture. All I have to do is say, well, I've got 3 atoms times a 2+ charge every time is going to give me a positive 6. So I can do that too. So you take the subscript, multiply it by the oxidation number, and you can get the charge of your total charge of that ion and how many atoms of that ion that you have. And this is why. Okay? So we're going to use subscripts. So we're going to be able to add these subscripts and change these subscripts to balance the charges. We are trying to balance some charges out until the compound is neutral. There's a word, neutral. If I'm looking to be neutral, I am looking to have a charge overall of 0. Okay, so if you need to write that in there, 0 charge means neutral. Okay, all right. Now let's look at this example that I've given you. You've got calcium and phosphorus, right? So you got calcium phosphide given the name. So we have calcium and we have phosphorus. The second step says to get the oxidation number. So that's exactly what I'm going to do. I'm going to get the oxidation numbers, which I did. Calcium has a positive 2. Phosphorus has a negative 3. Okay, that's where I got those numbers, and I got those numbers from the periodic table. Remember, calcium is here, right here. Let me just wipe some off the screen. Calcium has a positive 2, and phosphorus is over here with a negative 3. Okay, so that's where I got the numbers from. So I went and got their numbers, and then it says to add subscripts. So that gets a little confusing. So I want you to understand something. I'm going to add subscripts to try and balance this compound. This is an ionic compound, so I need to balance. If I look right here, these two things are bonded together. In this one I have a positive 2 charge, and this one I have a negative 3 charge. Okay, so those don't balance out to be neutral. I need to get it to neutral, so I want it to be 0. So when I add those two together, I get negative 1. That's not what I want. I want it to be 0. So when I think of 2 and 3, and you'll see this continually, think of least common multiple. What do they have in common? What can I get both of them to? I can't take anything away. I can only get them up to a common number that they share. So when I see 2 and 3, I think of 6, right? So if I think of this compound having 2 parts, it has a positive end and a negative end, okay? So I'm going to draw a line right there. This is going to be my positive end, and this is my negative end. I want to try to figure out how can I get both of these to be 6. I want this side of my compound to give me a positive 6 charge, and I want this side of my compound to give me a negative 6 charge because I want them to be neutral. I want those to cancel out. Well, right now I've got +2. The only thing I can do is add atoms of calcium. It's the only thing I can do over here. So if I do this, guess what? 2, 2, and 2 is going to give me a positive 6 charge. That's what I need. Okay? Phosphorus over here has a negative 3. If I add another phosphorus, that's all I can do is just add another one. I can't take anything away. I can't make it a different element. I just have to add atoms of this one to get it up to 6. A negative 3 and a negative 3 is going to give me a negative 6. And that's that side. So then if I look at my compound, I've got a positive 6 side. And then I look at this side, I have a negative 6 side, which is exactly what I'm wanting to do. And now I've got that key word right up here, I'm neutral. So I don't want to have to draw this out every time. That's too much work, right? That's too much work. It's not what we're doing. So I have a shorthand notation. I have 3 atoms of calcium, so I'm going to write that as Ca3. Remember, like we talked about, that subscript means I have 3 atoms of calcium bonded to 2 atoms of phosphorus. So I have 2 atoms of phosphorus right there, like that. So that is your answer when you are writing the compound calcium phosphide. Okay, there is a shortcut. So I'll show you the shortcut really quick on calcium phosphide. If I take calcium that has a +2 and phosphorus that has a -3, all I have to do is do something called crisscross applesauce. I bring the 2 down here, it loses its charge, it just becomes 2. I bring the 3 down, loses its charge, it just becomes 3 because it's going to tell me how many atoms I need. Then I have what I came out with over here, Ca3P2. It's the same thing. How does that happen? Because of this. Because what this is telling me, again, if I look at my line, 3 times 2 is a +6. 2 times -3 is a -6. And that's why it's going to balance. So you take your subscript and you can multiply it by your oxidation and you get your total charge of that side of the compound. Okay? So let's do some more of these. And I'll try not to go into so much detail, but use the shortcut to kind of help you understand what's going on there. So you can see the answers, and that's fine because we went over these in class. Just taking some time to go through these, and I won't go through every single one. So we look here, and you can already see that I have the answer. So the first thing I had to do is I think potassium sulfide. So that's potassium and sulfur, and I go to the oxidation numbers. I get +1 and -2, and then I use crisscross applesauce. So the 2 comes down here, the 1 comes down here, and when I write my final answer, I get K2S. Now, the reason I don't have to put a 1 here is because it's understood. If you put a 1 there, I'm not going to count it wrong. But on any type of testing and stuff, if you're looking for K2S1, it's not going to be a choice. K2S will be your choice. You have to remember that you assume that if there's not a subscript there, it's assumed that it's 1. Okay? So beryllium oxide, same thing. I have beryllium and oxygen. I go get their oxidation numbers. Look here, 2 and 2. Well, you think, okay, 2 and 2. Guess what? They already cancel out. So I don't have to crisscross applesauce because they already cancel out. They are a +2 on one side, a -2 on the other, which is what I'm wanting. So BeO is my compound. Now, what if you crisscross applesauce and you came up with Be, you put those down, Be2+, right, and O2-, and you crisscrossed applesauce and you said, okay, my answer is Be2O2. All right. That would not be correct. And the reason is because it's not in what you, if you think about this as like a fraction kind of, because it's a ratio, this would have to be in simplest form. 2 to 2 is not the simplest ratio I can get it in. So if you think about this as a fraction, that would actually reduce to 1 to 1, right? Or 1 to 1 ratio. So the simplest form is a 1 to 1 because those are both divisible by 2. So if you crisscrossed applesauce that, you're going to have to reduce it. If you just said, oh, +2, -2, that's already at 0, so I'm just going to move it over there and that's your answer. That's what I want you to see. And that may take some practice, and that's okay if it takes practice. All right, let's look at magnesium oxide. This is another one like the beryllium. Magnesium oxide, +2 and -2, they're already balanced, so MgO is my formula. Barium iodide, barium is +2, iodine's -1, so when you crisscross applesauce, you end up with 1 barium, I2, BaI2 is your answer there. All right, I'm just going to go through these really quickly. If you need to pause this, if you need to come see me, I'm here during homeroom, tutoring on Thursdays, so if you need to. Sodium nitride is sodium and nitrogen, +1, -3, crisscross applesauce, you come up with Na3N. Potassium nitride, +1, -3, crisscross applesauce, you end up with K3N. Barium phosphide, +2 for barium, -3 for phosphorus, crisscross applesauce, you're going to end up with Ba3P2. Aluminum bromide, aluminum is a +3, bromine is a -1, crisscross applesauce, you end up with aluminum AlBr3, and then remember that 3 just goes to the bromine. Aluminum is assumed that it's 1, but you don't have to put the 1 in there. All right, if I do the next one, calcium phosphide, Ca3P2, and I've got the oxidation numbers right there, so if you need to pause it, you can pause it. Magnesium nitride is going to be Mg3N2. Oxidation numbers in crisscross. Aluminum phosphide, this one here is 3 and 3, so that's already balanced, so ALP. Beryllium fluoride, 2 plus and a 1 minus, crisscross, BeF2. Calcium chloride, Ca2 plus, Cal minus, so it's going to crisscross, CaCl2. Strontium nitride, on yours I've had barium, but I've moved it to strontium. Nitride is going to end up with a 2 plus and a 3 minus, so Sr3N2. Barium nitride, Ba3N2. Beryllium chloride, BeCl2. Calcium oxide, CaO. You see those are already balanced. Potassium oxide is going to be K2O. Potassium bromide, KBr. Magnesium phosphide, Mg3P2. Lithium chloride, LiCl. And sodium chloride, NaCl, because those are already balanced. Positive 1, negative 1, positive 1, negative 1. So you notice some patterns here. You notice that the first one's always positive, the second one's always negative, the first one's always your metal, the second one's always your non-metal. You notice that the first one keeps its name, the last one ends in IDE. You notice that you always find your oxidation numbers and you crisscross applesauce unless they're the same. If they're the same, they already cancel, so you're good to go. If you crisscross applesauce, you have to reduce. All right, and so if you did not do this in class, do this, and then you have a practice page that has 20 questions that looks like this. And I'm going to put these up here and let it focus for just a second. You can pause it and get these answers because we went over these in class. So this is the the sheet that goes with it, simple binary ionic compounds. Okay, here's your answers. So pause it and get those. And then at the bottom, there's your answers there for 11 through 20 when I gave you the formula and you gave me the name. So pause that and get those answers. And if you have questions, come see me or come see Miss Guy or anybody else that can help you with it. So I'm going to move on to the next one with transition metals. If you need that, it's the next one on the video.